Hi folks, this is the 11th problem of the DSA series, so let's get started. Okay, so it says you are given an integer array heights I represents the height of the ith bar. Okay, you may choose any two bars to form a container. Return the maximum amount of water a container can store. Okay, so let's understand it with an example. So this is the array that we have been given. Here it says 186254837. So 186 and so on. So it is saying choose two bars to form a container such that the area between the container is the maximum one. Okay. So here it chose this 8 and this 7, right? Why? Because the area between those is 8 and 7. So this is the smaller one, 7 is the smaller one. So the area will be kind of 7 into where 7 is the height. Just a minute. Okay, where 7 is the height and we have to find the width in between, right? So this is the first element, 1 2 3 4 5 6 7 8. So 8 minus 1 7. So 7 7 ja 49. So the area will be 49 here, as you can see here, right? Now you might say why can't we take the two of the biggest heights, right? So this is the height 8 and this is height 8 as well, right? Okay, so let's take the biggest height. Now let's check the width. So this is at the first index. So 1 2 3 4 5 6. 6 minus 1 5, right? So the distance between these two bars is 5. So 8 5 ja 40. Now you can clearly see which area is bigger. This one is the bigger area. So yeah, that is what we got a return. So we got a return 49, right? So I guess you might have understood what we are trying to achieve. We are trying to get to the biggest area, right? So let's do it. Now this, there are two ways. One is we can have two loops, one nested into another, to check this. Another way is the two pointers way, right? So the first way will take O of n square time complexity. The second way has O of n time complexity. Let me first show you the first way very quickly. Function container with most water, it will take an array of heights. Let's name it heights itself. Now we can, what we can do is we can say loop for let I is equals to 0, I should be smaller than heights dot length I plus plus. Now in here let's have another for loop for let j equals to 0. This first will iterate over the index of the first bar. This second loop will give us the index of the second bar. And so let's start it from I plus 1, right? Because if this is like I, this is j, this like this is I, this can be j, this can be j, but this can't be j, right? J is smaller than, again we can say heights dot length and j plus plus. Now we can store the max area here. We can say let max equals to 0, and now we can calculate max. We can say const current area. So I just told you how the area can be calculated. For that we have to do j minus I, that is the distance between j minus I, distance between the indices, that is the width, right? So j minus I into, that is multiplied by whichever the smaller one, right? So multiply by math dot min, it is whichever is smaller, right? Because up to that level only the water will be present, right? So out of this 8 and 7, which is smaller? 7. So we'll do math dot min heights j into sorry, not into, it will heights I, so it will pick up whichever one is the smaller one. So this is the current area, that is the smaller one, into the width. This is the current area this container holds, and will iterate over each and every possibility here, right? This, then this, each and every possibility will be taken into account via this nested loop. Now here we can say, if max is smaller than current area, then simply say max is equals to current area. That's it. And here finally we can return the max. Now let's check it if this is actually working or not. Let's take this height, const height is equals to this. Now let's say heights, let's call it heights. Okay. Now we gotta run this. Let's see if this is working. The name is too long, container with most water .js. Yep, it seems to be working. 49 is the answer. Yep, it seems to be working. However, this has the time complexity of O of n squared, right? Because of this nesting. However, the space complexity is like nothing, okay, because we are not storing anything at all. This is a constant, right? But for the time complexity of O of n square. Now let me show you another way with time complexity of O of n, right? Now let me name it final, and here again it will take heights. Here we will take the two pointer approach. So let me first explain you the approach, then I will do it. So I'll take a pointer from left side and a pointer from right side. Let's call them, let's call the first pointer left, which will start from index 0, the another pointer right, which will start from index heights dot length -1, that is from this index, from the rightmost index, okay. And again we'll take let max equals to 0. Now what we'll do is we'll run a loop while left is smaller than right, okay. So yeah, we'll run a loop till left index is smaller than the right index. Then what we'll do, first we'll check this and this, okay, and we'll calculate the area, store it in max, okay. Now we'll see which one of the element, that is from the element present at the left index and the element from present at the right index, whichever is smaller, will move that index by 1. Here this is smaller, so we'll move this index by 1, and then we'll calculate the area here, okay. Again, if it is greater than the previous max, we'll store it in max. Now we'll see out of these two index whichever is smaller. So this is smaller, so we'll move this, then we'll calculate the area, and so on and so forth, and unless the left is smaller than right. If left is equals to right or left exceeds right, then we'll end the loop, and whatever max we have stored will return that. So let me do it and you'll understand it better. So you understood, no? We'll do left is smaller than right, so until this point, in this case until this point, right, because here left and right both are equal, we can't move any of the two forward, else the loop will end, okay. So yeah, let's do this. Now here we'll check if so here let's calculate, right, first let's calculate the current area. Const current area is equals to math, yeah, same, math dot min, here we'll say heights left, because this left is it gives the left index, and then heights right, this gives the right contains the right index, right. So this is the element which is present at the right index, this is the element present at the leftmost index, whichever is the minimum multiplied by the distance, right? The distance, it is the width distance, it is right minus left. So this is the current area. Now we'll say, if, again the same thing, if current area is greater than max, then simply do max is equals to current area. Okay, now we gotta move the pointers from both sides now. Okay, so we'll check whichever is smaller, we'll move that one. Understood? So we'll check heights left, whichever is smaller, we'll move that one. Heights right, if both are smaller, like if both have equal heights, we'll move the, like let's move the left one, right? If both have like if this, in this case both have equal heights, we gotta move like any one, so move this one, right? Let's move left one only. So we'll check, if heights left is smaller than or equal to heights right, then simply do left plus plus, else do right minus minus, because from the right index we got a decrement, from the left index we got an increment to move, right? So yeah, this should give us the maximum area. Let's return max and let's freaking check if this is working. Final. Okay, it should give us 49. Okay, we got okay, so it is giving us 49. So yeah, this is working as well. And now it has a time complexity of O of n, because we are iterating for only one time in this while loop, right? So yeah, let me just push this code, and that's all from my side, guys. Thanks for watching. Let me just stop the recording.